Welcome to this short tutorial produced by CertaSIM LLC. It covers how to build a model in the IMPETUS AFV Solver GUI assembly mode when we have an existing mesh file. So the setup we have here is a ballistic impact. We have a termination time of 1 e to the minus 4. We have half symmetry, and you can see we have a constraint here along two of the edges. We're using SI units, and we have a 3-component bullet coming in with a jacket, a core, and a tip, with an initial velocity of 875 meter per second. We have used cubic elements, and we have a refinement in the zone where the bullet is impacting the target. The mesh here is just nodes and elements, and that's what we're going to build the model from. This mesh can be done in any of the preprocessors like ANSA, HyperMesh, or CSIMsoft Bolt and Trellis. Let's start building a model. We have a file here that's the mesh file. It's linear_mesh.k. If we go in and look at the file, we can see here that we have star node. So here is a list of nodes. When we come down here, then we have elements. So there are no material definition, no part definition, no boundary condition, etc. It's only nodes and elements. So let's now start building the model. So we'll start with a new file. Start in Solver GUI, new file. Let's call this one ballistics. This automatically gives it .k, so we know what format it is. We'll just start in the assembly mode. Now this is where we are working today. Basically on this tutorial will be mainly in the insert in the assembly mode, because we want to insert different commands and mesh files into a model. So we'll start with a mesh, the mesh we just looked at. It's called the linear_mesh.k. Here you have the option of scaling it, and also you scaling the geometry, and you can offset node IDs and part IDs, etc., depending on what you have in your model and how you want to structure your IDs. But we'll just accept this, and then we can zoom to scene, and here is the geometry, which is the target and the 3-component bullet. Now let's start with parts. So we click on this one here. That is the target. So let's make it a little structured here. Call it target. As you saw, there was no material IDs, or no material specified. So we can either assign it from a library, built-in library of different materials, or we can create a material ourselves. Let's just assign one for the material library. Here's a list of the different materials that are verified, come from the literature and experience. And here you can see all the documentation for that specific material. So we'll use this AA5083. When I right click, use the right mouse button and click it one time, everything is accepted what's in that area down here. See, now it's target. Let's do the jacket. Part 2, we'll go down and select the material, and let's take a copper jacket. So all the materials in here is the NATO 762 ball bullet. There's the jacket of this one, so we say okay. We have material 2. Let's take part 3, which is the core. So let's call it core. But this time let us create a material instead. So let's create one, and let's just say we have a rigid mat_rigid. Let's call it core material. And then we need to give a density. We only have to give a density. We're working in this SI units, so 7800. And then we need the last part, which is the tip. And we can select one from the material library. Let's just go in and take a high strength steel, and that'll be number 4. Now we have named them the different parts in here, and we also have assigned them materials. These materials here were temperature dependent, so let's just go in and assign an initial temperature. Again, in insert, I add a command. This is then all the commands that we can work with. Then we have initial conditions, and you can see here that I have starred some of them. That means they'll come up here immediately when I go into the to add command menu. So it makes it easier because there's a lot of these that are the same that you have to build for each model. Entity type, let's do it for everything. And then we have to give a function, so I can need a create a function. In this case, my function is just a constant. So I will just go over here and say 293 Kelvin. And now I have initial temperature, function 1, and I have my function here. We'll go up here on the file and just save periodically. It's always a good thing to define the units, especially when we are doing these materials that are unit dependent, taken directly from the material library. So let's go in and insert on the simulation control. I can put in the units here, SI units. I can also give the time, and let's just say 1e minus 4. And everything comes up here under the object tree, as you can see, and we can move it around here so you get more area here. I can also go in and look in the editor. Remember, now we're in assembly mode here. I can go into the editor mode and then ask, do you want to save it? Yes, I should always save it before I go to the edit mode. And here you see what we have so far. Material, parts, time, include the mesh. Let's go back to assembly mode and look at these elements here. We want to make these cubic elements because they are all linear course from the generic preprocessor, the output from the generic preprocessor. So we like to work with higher order elements, and we can easily do that. We go to add commands. I have change p order, which is actually will be under nodes and connectivity, but I have it start over here. I could just give it a title, change all elements, and entity type will then be all, and the order will be 3. I click on the right mouse button, it's accepted. Let's just save this. So in the assembly mode here, we can't really see that we just turned these elements into cubic elements. They're still shown as linear elements. But we can go into the preview mode. There we will see the cubic mesh. So let's just see preview here. Say yes. Now we'll run an initialization and use this command. If we go and look at the elements here, we can see these cubic elements. So we now see that we have turned each of these old linear elements, as there was in the original mesh, we have turned in to cubic element. We've done that for all parts, as you can see. One thing we want to do now is that we want to refine the mesh for the target here when the bullet comes into impact here. So just this area here. So let's go back to assembly mode. The way we do that is with a command called refine. And it can be based on parts, but it can also be done just for geometry. So let's make a geometry out of a pipe that's just around here. So we'll go to insert again. We'll add a command. We'll go to geometry. We'll take a pipe. We can call it refinement. Geometry 1. Now we need to know what this point is. So if you push N on the keyboard, and now you have to click with the mouse in the graphic window. Then you click N and we can now get the node. So that's 0, 0, 0, and we get the coordinates as well, as you can see. And this one here is 0, minus 0, point 0, 25, and 0. These are the coordinates, and I can hit escape here, and then I get out of this. We want to get back into our refinement command. We continue editing that. So you can see I pushed in when I was at the keyboard. That's why I got an error there. So let's say that was 0, and it'll be 0, 0, because I need to define a pipe here. So I need the endpoints, and we can do 0, and then it was minus 0, comma 0. This is in the y direction. 20. Let's just add a little bit, and we can do the same thing over here. So it'll be 0.01 and 0. Then we're a little bit outside the geometry. Then we need to find radius. Could be, let's just say e minus 3 here. Oops, I think we should say minus 2. Yeah, that would be better here. That would probably be good. The good thing is that you saw here, we could actually just, as soon as we type in there, the geometry would be shown, so we could get a feeling of how big it was. Now that should be good. Now we have a geometry. Now we need to insert the command to do the refinement, and that is called refine, and it will be under, we have it under mesh commands. So this is listed according to functionality. Let's just go in here and say okay. Well, we do it on a part. It is the target, but now we only want to do a part of that part, so to speak, an area of that part. That's why we use a geometry. So the geometry ID was refinement is 1, and then we need to tell the solver how fine do we want it. We want it to have it level of refinement 3. We accept that. Again, we can't see this one here. Let's just go and save this file and go to preview, and we'll see if we get the mesh that we're expecting. You can see now if something is definitely changed here. And yes, we got a much finer mesh here. Let's go back and continue here, because now we need to have some boundary condition. Now we basically have done the things with the mesh and the materials and the parts and simulation time, etc. So let's continue to boundary condition. So this is a half symmetry. So let's go into insert, add command, boundary condition. It's a symmetry. And the plane that we're doing this in will be C. And we can put in a tolerance. Yeah, you can see the plane here comes up immediately. That's the plane that we want. Put in a tolerance. Let's say 1 minus 5, for example. We also had some other boundary condition, is that we want to have it fully constrained along this side. And how do we do this? Well, we use the command called BC motion, both to prescribe motion and boundary conditions. So I'll add a command, boundary condition, BC motion. But what I really need in here as well is that I want to grab these nodes. So I could, of course, make a node set, but a smarter way is actually to use geometry. So let me try to create a geometry based on a seed coordinate. I don't want to do it based on nodes, because what if I change the mesh? So let's do a seed coordinate. And we can just call this constraint. This is now geometry 2. In operation, I can go in and select a coordinate, which I will do right here. Now I've selected this. And now I can go in, back into my motion. And I can go in and take my constraints, take the geometry, we take the seed coordinate, let's find this one. And I want to do, these are solids, so let's just take TR stands for translation. Take the translation. And now I have made my constraints for this model. So the bullet here, we want to give an initial velocity so it can impact the target. Let's go in and do that on a part set. So let's go to add command, and then we'll go to sets and set part. Say OK. Now if I go on to operations here, I can pick the parts. So that would be 2, 3, and 4. Let's just do that. Now I right click in it, I go to set part. You can see they're here 2, 3, and 4. And that was my part set number 1 here in my object 3. So we go to initial conditions. We want to do initial velocities. Again, this is one of my start commands. It's a velocity. We want to do it on a part set. And now I can go down and see what part set do I have. It's really nice that they come up listed here, whatever IDs I have in there to select from. Part set number 1 is in the Y direction, and we had 875, it'll be in negative direction. And that would be it. Now we also need to have a contact for this model. Of course, there is a contact between the bullet and the target, but we should probably put in a general contact because we can see the bullet here. It could come in some contact here when it starts deforming. So let's go and add contact. Let's do this contact here. So we just call it general contact. And since we're using all, we can just do all and all. Slave and master here doesn't really matter because it's a symmetric contact. And this contact in impetus, there's only one contact formulation. It covers everything, eroding, etc. We can go in here and we can just put a friction in like 0.1. Then we have the stiffness of the contact. I could give it a number here, but I like to start with just let the code calculating the contact stiffness. Since we have put in the unit system, it can do that now, but it can also be more advanced, and the contact stiffness can be calculated based on what kind of applications you have, which in this case is ballistics. So let's just go and select that as well. So we should have everything here now for the contact. Let's just go and save again. And let's put in the type of model we have. So that will in solution control and techniques. We'll take this, it's the explicit, and we have ballistic simulation. We should be ready now to finish this model. So let's just put an end in there. That's input handling. Now we should have end in there as well. We can go in and we can again check it in the editor. Just if you feel more comfortable with that, it's always a good idea to do that, in my opinion. You can scroll down, see all the things we have. We had the contact, initial velocities. We had from the beginning the include mesh file, the target, the material library, the time, etc. So this means that we now can go in and we can start the simulation because we have now finished the modeling. We have finished a model that's based on a generic mesh. The start of a simulation is covered in other tutorials. This concludes our tutorial on building an impetus model with a preprocessor-based mesh geometry, and we hope that you have enjoyed watching. If you have any questions, please contact us via support@CertaSIM.com. Have a great day.